today's video, we are going to talk about how to find the derivative of cosecant x using delta process, and we are going to explain everything in details. So as you can see, we have f of x equals cosecant x, and the delta process, that is f of x, is equal to limit of f of x plus h minus f of x all over h as h approaches 0. Since we have f of x, which is cosecant x, let us have the value of f of x plus h, that is cosecant x plus h. So let us substitute this one to the given formula. Let us have limit h approaches 0, f of x plus h, that is cosecant x plus h, minus f of x, that is cosecant x all over h. And to simplify this one, let us have limit h approaches 0. The reciprocal of cosecant is 1 over sine. So since we have cosecant x plus h, this will be sine x plus h minus the reciprocal of this one, that is 1 over sine x all over h. And then let us have limit h approaches 0. So let us write h on the denominator together with sine x times sine x plus h, and then cross multiply sine x times 1, that is sine x minus 1 multiplied by sine x plus h. So let us simplify this one. Let us have limit h approaches 0. Let us rewrite sine x minus, since we have sine x plus h, let us use the sum identity for sine, that is sine x cosine h plus cosine x sine h all over sine x, and then we have sine x cosine h plus cosine x sine h all over h. So we are going to multiply h on this one, and let us distribute the negative sign inside the parentheses. So this will give us limit h approaches 0. We have sine x minus sine x cosine h. Negative times positive is negative. Cosine x sine h all over h sine x times quantity sine x cosine h plus cosine x sine h. So let us have limit as h approaches 0. Since we have sine x in common, so let us factor this one. So let us have sine x as the factor. Sine x divided by sine x, that is 1. And then negative sine x cosine h divided by sine h, that is negative cosine h. Let us write cosine x sine h all over h sine x times quantity sine x cosine h plus cosine x sine h. So in order for us to simplify this one, let us separate the denominator. This will give us limit h approaches 0 sine x times 1 minus cosine h all over h sine x times sine x cosine h plus cosine x sine h, and then minus limit h approaches 0. We have cosine x sine h all over h sine x times quantity sine x cosine h plus cosine x sine h. And then, since we have limit of 1 minus cosine h times h, that is 0. And if you're going to multiply this 0 by sine x and divide by this expression, the answer is still 0. So meaning to say, the value of this expression is equal to 0 because of the limit of 1 minus cosine h all over h as h approaches 0. And then, on the other side, we have here cosine x over sine x times limit of sine h over h as h approaches 0 times limit h approaches 0 times that is 1. And then let us copy the denominator sine x cosine h plus cosine x sine h. So as you can see, we have cosine sine on the numerator times 1, still cosine x sine h. And then we have sine h and this expression. So to simplify this one, let us have 0 minus cosine over sine, that is cotangent x, and the limit of sine h over h as h approaches 0, that is 1. And then we have 1 over sine x cosine 0 plus cosine x sine 0. So this will give us negative. We are going to disregard this one. Cotangent x times 1, that is cotangent x times 1 over sine x times cosine 0, that is 1. And then we have sine 0, that is 0, times cosine, that is 0. So to simplify this one, we are going to have negative cotangent x times 1 over sine x. And 1 over sine x, that is cosecant x. So we have negative cotangent x, cosecant x, or we can write our answer as negative cosecant x, cotangent x. So therefore, this will be the derivative of cosecant x. So I hope you've learned from this video. Thank you so much for watching and God bless us all.